Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, episode 17 of 24. When a user complains the AI gave them a bizarre answer 3 days ago, how do you pull up the exact prompt that caused it? Parsing application logs for multi-line JSON payloads is a nightmare. You need structured trace data, but building custom integrations for every monitoring tool drains engineering hours. This exact problem is handled by drop-in observability. Instead of writing custom wrapper functions to time your API calls, count tokens, and catch timeouts, LiteLLM intercepts the traffic natively. It exposes two core hooks inside your settings, the success callback and the failure callback. These callbacks act as automatic routing mechanisms for your telemetry. They accept an array of strings representing supported external observability providers. You simply name the tool you want to use, and LiteLLM translates its internal request data into the exact format that specific tool expects. Take the success callback. This triggers the moment a language model returns a valid response. When this happens, LiteLLM automatically captures a snapshot of the transaction. This includes the exact input prompt sent to the model, the generated output, the time it took to generate, and the precise token usage. To send this data to an external tool, you open your LiteLLM settings and set the success callback variable to a list containing the string Langfuse. As long as your Langfuse authentication keys are present in your environment variables, the system handles the rest. Here is the key insight. The logging process happens asynchronously in the background. Your main application thread never blocks while waiting for the observability provider to acknowledge the trace. Your users experience zero added latency. That handles the happy path. For the errors, you use the failure callback. This triggers when an API call times out, hits a provider rate limit, or fails completely. Without proper tracing, an LLM error often surfaces as an opaque status code. By setting your failure callback variable to a list containing the string Sentry, you map LLM exceptions directly to your existing error tracking workflow. When a request fails, LiteLLM packages the exception type, the model name, and the attempted input, then pushes that context directly into Sentry. To set this up in your code, you do not need to modify your actual API calls. You only touch the global configuration. You assign your chosen tools to the callback arrays once during application startup. From that point forward, every completion call you make is monitored. Your core logic remains entirely decoupled from your logging infrastructure. If you decide to swap Langfuse for another provider next month, you change one string in an array. The true power of drop-in callbacks is not just avoiding boilerplate code. It is standardizing the shape of your telemetry across dozens of different LLM providers so your monitoring platform sees exactly one consistent format, regardless of which underlying model answered the prompt. Thanks for listening. Happy coding, everyone.